Welcome to StackTrekker. In this tutorial, we're diving into Docker, what it is, why developers use it, and how you can get started with containers, even if you've never touched Docker before. By the end of this session, you'll understand the core concepts, run your first containers, and launch a real web server using Docker on your own machine. Let's get started. To really understand Docker, let's take a moment and talk about why this technology even exists and who it's actually made for. Software today is more complicated than ever. We have different programming languages, different libraries, different versions, and all kinds of dependencies. And if you've ever tried to run someone else's project on your computer, you already know what happens. It works on their machine, but not on yours. And the reason is simple. Your environment is not the same as theirs. Your operating system, your installed packages, even small configuration differences, all of that can cause an application to fail. This is the exact problem Docker was created to solve. Docker gives your application its own little world, a completely isolated environment called a container. Everything the app needs is packaged inside that container. Its libraries, its tools, its configuration, even its own mini file system. And because Docker controls the entire environment, the application runs exactly the same on every computer. It doesn't matter if you're on Windows, Mac OS, or Linux, a Docker container behaves identically everywhere. So who is Docker for? Honestly, almost everyone in software development. Developers use Docker because they want predictable, stable environments. DevOps engineers use Docker because containers are easy to start, stop, deploy, and scale. Testers use Docker to create clean test environments that reset in seconds. Students and beginners use Docker to learn new tools without breaking their main system. And companies use Docker because it makes their applications portable and reliable. So, what problem does Docker solve? It removes the chaos of setting up and maintaining complex environments. With Docker, you don't install tools on your computer, you run them inside containers. PostgreSQL, Redis, Python, Java, Node.js, everything becomes a one-liner. And here's the part that changed the industry. Docker containers are incredibly lightweight. They are not virtual machines. They don't include a full operating system. They start in less than a second, and you can run dozens, even hundreds, on a single machine. That speed and simplicity is what made Docker explode in popularity. Before we can start running containers, we need to install Docker on your computer. The good news is, installation today is very simple. Docker provides a single application called Docker Desktop. It works on Mac OS, Windows, and Linux, and it gives you everything you need to run containers locally. Let's walk through the installation. If you are on Mac OS, go to the Docker website and download Docker Desktop for Apple Silicon or Intel, depending on your Mac. Open the installer, drag Docker into your Applications folder, and launch it. The first startup may take a few seconds because Docker is setting up the background services that make containers work. You may need to grant some permissions. Before we continue, remember this. Installing Docker doesn't change your system in a dramatic way. It doesn't replace your environment. It doesn't take over your applications. It simply gives you a controlled, isolated space to run tools and services without touching your main system. And that is exactly what makes Docker such a safe and beginner-friendly technology. Now the Docker Desktop is installed and running, let's take our first real steps inside the Docker interface. In Docker Desktop, go to the Docker Hub section. This is the built-in browser for Docker Hub, which is the public library of container images. Think of Docker Hub as the app store for Docker. Thousands of ready-to-use components, from databases to web servers to developer tools. In the search box, type "Welcome to Docker." You'll see an official starter image created specifically for beginners. Select it and press Pull. Docker will now download the image to your machine. When the download finishes, open the Images tab in Docker Desktop. Here you will see a new entry, the Welcome to Docker image. So, what exactly is an image? A Docker image is a blueprint for a container. It contains everything the application needs: the code, the runtime, the libraries, the file system layout. It is read-only, it never changes, and every container you create from that image will behave the same way. It's like a template. You can run many containers from one image, just like making many copies from one master file. Now let's actually run it. Go back to the Docker Hub page for Welcome to Docker. There, you will see a section called Run with Docker. Copy the command shown there. Open your terminal and paste the command. Press Enter. Docker will start a new container from the image. Nothing else is required. No installation, no configuration, no setup. Docker handles everything inside the container. Go to the Containers tab. You will see a new container running. This is your Welcome to Docker application, fully isolated and controlled by Docker. The last step is to open it in your browser. Go back to Docker Hub and copy the URL shown there. Paste it into your browser. And that's it. You're now viewing a real application running inside a Docker container on your machine. In just a few minutes, you installed Docker, pulled your first image, started your first container, and accessed it through your browser. You didn't install any dependencies, you didn't configure a server, you didn't set up anything manually. Docker did it all for you. Okay, now let's take a look at how starting and stopping a container works. Go to your running container and click the Stop button. Now switch back to your browser and refresh the page. You'll immediately see an error. The browser can't connect anymore. And of course it can't. We just stopped the server that was running inside Docker. Let's start it again. Go back to Docker Desktop, press Start and reload the page. Everything is back online, exactly where it was. This is one of the great things about Docker. Stopping and starting services becomes effortless. Now let's explore what else we can do with a container. Open the container's details. Here you can see everything that's happening inside. Logs. This shows the live output from the application running in the container. Inspect. This gives you all the configuration details Docker uses behind the scenes. Terminal. And this one is really interesting. When you open it, you get a real shell inside the container. From here, you can explore the container's file system just like any normal operating system. You can list files, open directories, run commands, everything. But remember, this environment is completely isolated. If you break something, nothing happens to your real machine. You just delete the container and create a fresh one from the image. It takes seconds. You can also check the Statistics tab, which shows CPU usage, memory, network activity, all the metrics you need to understand what your container is doing. Now that we've explored it, let's remove the container. Click Delete. And just like that, the entire environment is gone. But the image is still on your machine, so you can recreate the container whenever you want. Now let's take one more important step, removing the image itself. Open the Images tab in Docker Desktop. Find the Welcome to Docker image, the one we pulled earlier. Click Delete Image. In a moment, the image disappears from your system. And this is exactly how Docker is designed to work. Containers and images are lightweight, disposable, and easy to clean up. You're never locked into anything. You can always remove old environments and start fresh. At this point, you've walked through the full life cycle. You pulled an image. You created and ran a container from that image. You explored its logs, settings, terminal, and statistics. You stopped it, started it again, and finally removed it. Then, you deleted the image itself. This simple example shows the power of Docker. In just a few clicks or a single command, you can set up, run, explore, stop, and remove complete environments without touching your actual system. Now that you've seen how to work with images and containers inside Docker Desktop, let's move one step further and start using Docker the way most developers actually use it, from the terminal. You can use the terminal inside Docker Desktop or your system terminal. Docker Desktop is great for visual learning, but the real power of Docker comes from its command line tools. They let you automate tasks, script your workflows, and integrate containers directly into your development process. And the best part is, the commands are simple. The first command is used to pull or download an image from Docker Hub to your machine. This tells Docker to fetch the official Nginx web server image from Docker Hub. Docker will download all the layers that make up this image and store them locally, so later you can create containers from it instantly, even without an internet connection. In other words, pulling an image is like installing the base template you will use to create your containers. The next command is used to run a container from an image. Here, the image name is nginx, which is the official nginx web server image. Some containers need to communicate with the outside world, for example, with your system browser, so we need to allow that. Here's what each part of the command means. This runs the container in detached mode, which means it starts in the background and doesn't block your terminal. This tells Docker to map port 80 inside the container to port 8080 on your machine. In other words, Nginx still listens on port 80 inside the container, but from the outside, you access it through port 8080. Once the container is running, open your browser and go to localhost 8080. You should now see the default Nginx welcome page, served directly from inside your Docker container. This confirms that the container is running correctly, the ports are mapped properly, and your browser is communicating with the web server inside Docker. This command is used to stop a running container, but to stop a specific container, we first need its container ID. To get that ID, we run a command that lists all currently running containers. From this list, we can copy the container ID and then use it in the stop command. Before executing the command, let's check the current status. We can see that the container is running. Now we run the stop command and then check the status again. The result, the container has stopped successfully. But even after a container is stopped, it still exists, and you can start it again at any time without any issues. If you want to permanently remove the container, you'll need to use a different command. This command removes a container completely, and just like before, you must provide the container ID. Let's run it and check the result. As you can see, the container is no longer listed. It has been fully deleted. So everything you previously did through the Docker desktop interface can also be done with just a few simple terminal commands. And this is exactly how developers work with Docker in real projects. Now let's go through a complete real-world example using PostgreSQL inside Docker and connecting to it from dbeaver. First, we need to download the PostgreSQL image. In the terminal, type docker pull postgres. This command downloads the official PostgreSQL database image to your machine. Next, let's run a new PostgreSQL container based on this image. Let me break down what each part means. The docker run command creates a new container and starts it immediately. This option runs the container in detached mode, so it works in the background and doesn't block your terminal. Next, this part gives the container a custom name. This makes it much easier to start, stop, or remove later. This sets an environment variable inside the container, and PostgreSQL uses it to create the default Postgres user with this password. For learning purposes, this is fine, but in real projects, you should use a stronger password or secrets. The next part tells Docker to map port 5432 from the container to port 5432 on your computer. This allows us to connect to the database from tools like dbeaver or from our application. And finally, Postgres is the image we're using. This starts a fully working PostgreSQL database in the background. After running this command, PostgreSQL is now up and running inside a container and we can connect to it. For this demonstration, I'll use dbeaver, which is a popular database management tool. First, we need to create a new connection to our database. Because the Docker container is running on our local machine, most of the parameters are already correct. First, the only thing we need to enter is the password we set earlier, admin123. And that's it. We are now connected to our PostgreSQL database, and we can start working with it. Let's create a table and fill it with some data. Here I'm creating a simple table called items, with two fields, a primary key named key, and a text field named name. After executing the statement, we can check if the table was created successfully. Next, let's insert some data into it. Once the insert statements are executed, we can run a simple select query to verify the result. And here it is. The data is stored in the table exactly as expected. So now you've seen how easy it is to spin up a full PostgreSQL database using just one Docker command, and how quickly you can start interacting with it through dbeaver. No manual installation, no configuration problems, everything runs instantly inside an isolated environment. Now that we've worked with ready-made images from Docker Hub, let's take one step further and do something much more powerful. Let's create our own Docker image. This is how developers package applications, websites, and entire services so they can be started anywhere with a single command. First, let's create a new folder for this small project and move into it. Next, create the HTML file that our Docker container will display. Still in the terminal, open a text editor. Inside the editor, type this. To save and close the file in Nano, press Ctrl-O to write the file, press Enter to confirm, then press Ctrl-X to exit the editor. Now let's create a Docker file. Again from the terminal. Inside it, write two simple instructions, and again to save and close. Ctrl-O, then Enter, Ctrl-X. Now we can build the image. In the same folder, run this command. This gives the image a name, and the dot at the end tells Docker to use the Docker file in the current directory. Once the build finishes, let's check that the image exists. So this is our newly created image. Let's run it. This starts a container in the background and maps port 80 inside the container to port 8080 on our machine. If we now open the browser and go to localhost port 8080, we see the message from our HTML file, but this time it's being served from inside a Docker container using our own image. Now let's do something interesting. Let's update the index file. Open the file again, change the text to something new, and save it. Since we modified the file, we need to rebuild the image so Docker includes the updated content. Our old container is still running, so we need to stop and remove it. First, list all containers to find the container ID. Then stop the container. Let's check if it worked. Refresh the browser page and we see that the server doesn't respond anymore. Now we can remove the old container so it doesn't conflict with the new one. With the old container removed, we can now create a fresh container from the newly rebuilt image. After refreshing the browser, the updated message appears immediately, confirming that the new image is being used. And notice how fast the rebuild was. Docker didn't recreate everything from scratch. Thanks to layer caching, it only rebuilt the part that changed. And that's it. In this tutorial, we went all the way from understanding what Docker is to creating our own Docker image. Of course, we only touched the basics. Docker offers many more powerful features, but this is enough to spark your interest and give you a solid foundation to continue exploring the technology. So I hope this was interesting. Thank you for watching my tutorials. If you enjoyed this, please like the video and subscribe. See you later. Bye.